Hey everyone, today's lesson will be on Barycenter. The objective of this lesson is to demonstrate how objects orbit each other at their barycenter. So, before you begin, on your guided notes, draw an arrow that points to the center of mass or balancing point of each object. Take about 3 or 4 seconds to do this. Okay, so the center of mass that I determined for the ruler was right in the middle. And then the center mass for the sledgehammer was more towards this side, kind of where the hammerhead actually is. So I want you to ask yourself, in your guided notes you can also answer this question. Why is the ruler's center of mass at a different location than the sledgehammer? So why is the ruler's center of mass in the middle, while the sledgehammer's center of mass is towards the hammerhead? At this time, there is no right or wrong answer. I just want you to make your best guess or, your best educated guess. Take a few seconds to do this. So let's start thinking about barycenter. But before we go into what barycenter is, let's review what an orbit is. An orbit is a gravitationally curved path of an object around a point in space. So here's a quick video. So you see these planets, they are all orbiting around what we would see in the middle is the sun. What you will notice in this demonstration is that it's very similar to the law of harmonies. So remember, the law of harmonies was one of Kepler's law that states that the further away a planet is, so the further out you come from the sun, you notice that it moves slower. Its orbital period is much slower. But the closer the planet is, the faster or shorter its orbital period is. Okay? So let's review. What is a center of mass? You've probably heard this concept in the past, maybe in middle school or in another science class that you've taken. The center of mass is the exact center of all the material an object is made of. So an object's center of mass is the point where it can be balanced. So this is often referred to the center of gravity. So a good thing that just happened in the news that actually relates to this is how we were talking about on a certain day in February, NASA said that a broom could stand up without, being held up by anything. But actually, it wasn't just any day. Realistically, it could have been done any single day of the year. If you took your broom and found where the center of mass of the broom was, you'd be able to still stand the broom up on its own. So, if you're at home watching this video, totally give that a try. So let's review, or not review, let's kind of talk some more about orbiting. So how do objects orbit each other? When a moon orbits a planet or a planet orbits a star, both bodies are actually orbiting around a point that is the center of mass or the barycenter of the two celestial bodies. So all this is saying is that when something is orbiting another object, so let's say a moon is orbiting a planet, the point between the moon and the planet where they balance each other out or where their center of mass is called the barycenter. So let's see, what is the barycenter? What a weird word, right? So in space, two or more objects orbiting each other also have a center of mass. So we just went over that. It is the point around which the objects orbit. So this point is the barycenter of the two objects. The barycenter is usually closest to the object with the most mass. So in this case, these are our two binary bodies. The sun is binary body 1, when Jupiter over here is binary body 2. So the barycenter between the sun and Jupiter is closer to the sun because the sun has a greater mass than Jupiter. So this is where the two objects are orbiting about, this little dot here, which we refer to as the barycenter. So what are binary bodies? So we just touched on this really quickly. Binary bodies are two celestial bodies held together by mutual attraction. So an example of this would be the Earth and the Moon. or the sun and Earth, or the sun and Mars, or even back in this example, the sun and Jupiter. So those are binary bodies. Oops. So words worth knowing for this lesson is celestial. So celestial means position in the sky or outer space. And another word that is worth knowing is mutual. Mutual means it's held in common between two or more parties. So you could say you have mutual friends, for example, meaning you had the same friends as another person. So what I want you to do, or I guess we can pull this up on the screen. What do you notice about the movement of two binary bodies as they orbit each other? So I'm just going to pull this up really quickly. And what we want to get to is this simulation at the bottom. So from this simulation, this one and this one, I want you to ask yourself, what do you notice about the movement of the two binary bodies as they orbit each other? So I'll give you a few seconds to look at this. What do you notice? What do you see? There's no right or wrong. Just what do you observe? Okay. And then lastly, let's practice determining where our barycenter is. So remember, our barycenter is always going to be closer to the object with the most mass. So in example 1, these two objects look like they are about the same size, so they probably have the same mass. So our barycenter would lie right in the middle. And then example 2. So you notice that this binary body is much larger than this binary body. So we could think that because of its size, this binary body probably has a larger mass. And therefore, our barycenter would be closer, somewhere around here. And then this, example 3, is just the flip of 2. So remember this one, this binary body on the right, looks like it has a larger mass than 3. So our barycenter would be closer to this example. Okay? So that's it for today's lesson. Make sure you complete your guided notes. Make sure that you've completed your do now. Once you're done with this, you are more than welcome to move on to your independent practice and your exit ticket. Have a nice day, everyone.